Looking at, we're going to continue talking about inverse functions for square root functions. And yesterday we just did the verifying or proving the inverses using composition functions. What we're looking at today is describing the relationship of inverses between the quadratic and square root functions. So in the relationship of the inverse of quadratic, which I'm going to remind y'all, quadratic, that's when we have x squared. So whatever equation has the x squared, and the square root functions, okay, that's the one that has x under the square root symbol. Okay, so in the relationship of inverses between those, the domain of f of x becomes the range of the inverse of f of x. And the range of f of x becomes the domain of inverse f of x. Essentially, we're just switching the domain and range. That's what's happening here. Because we know in inverse functions, inverse means the x and y switch. So that means the domain and range are going to switch. So the x values become the y values. Okay, the y values become the x values. So these are the steps that these were listed on yesterday's notes. I told y'all we'll focus on those tomorrow. Well, now it's tomorrow. So we're going through the steps of finding the inverse by, first of all, we're going to replace f of x with y, switch the x and y, solve for y, and then rename it inverse of f of x. So here is our first equation. We're given this quadratic, but with a restricted domain. Okay, so it's a normal quadratic, but then it says for the domain of 1 to infinity, where 1 is included. So make sure you understand this is a restricted domain. Now, I'm actually going to rewrite that domain. Right now it's an interval notation. I'm going to write that in inequality notation because that's how you have to type it in Desmos. And I'll show you that in a second. But from 1 to infinity means everything greater than 1. And because that's a bracket, that means 1's included. So domain is x's. So this is saying x is everything greater than or equal to 1. So that's the first thing I'm going to do is I'm going to rewrite that as an inequality. Okay, now we're going to find the inverse and graph the inverse. We're going to graph the original, find the inverse, graph the inverse. So the original function, we can see this is shifted 1 right and 2 up. So our vertex that's normally at 0, 0 for a quadratic is over 1 up 2. And you can also use Desmos to graph this. You don't have to graph it by hand. Okay, and then it's not stretched or compressed. The A is still an understood 1. So we know that there's a point over and up 1 or over 2. 4. Now, I am not going to mirror those points across the normal axis of symmetry because of this restricted domain. It's not the full parabola. Everything greater than or equal to 1. So it's this x value of 1 where we put the vertex and everything to the right. So it's only half, and man, that did not hit that last point. It's only this half of the parabola that I'm graphing. So that's the given function with the restricted domain. Now the inverse, I can go ahead, I don't even have to know the inverse to be able to switch the domain and range because we just got through talking about that. The domain is going to become the range of the, oh, well, this is for the original, sorry. So the domain is everything greater than or equal to 1. Now the range is low to high. This low point, the y value is at 2. So the y is everything greater than or equal to 2. Now for the inverse, this is what I was saying. I don't even need to know the equation yet. I can just switch the domain and range. Now I have to switch the x and y because range is always y, domain is always x. But notice I switched the numbers, okay? So the domain was greater than or equal to 1. Now the range is greater than or equal to 1. The range was greater than or equal to 2. Now the domain is greater than or equal to 2 for the inverse. Okay, I plotted these points. I didn't list them in the table. If you want to, you can. This first point I plotted was at 1, 2. Then there was a point at 2, 3. And then there was a point at 3, 6. Those are the only ones I plotted. 3 is enough. Now you're going to flip those for the inverse. What is the x becomes the y. What is the y becomes the x. So that's just going to flip. So let me actually choose a different color to do this in. Graph the inverse in red. So plot these points at 2, 1, 3, 2, and 6, 3. I'm going to plot that curve. And there it is. And you can see the visual of those inverses. And you can confirm with what I said yesterday. Remember I said yesterday, they're a reflection across the line y equals x. If you want to draw that line y equals x there, these reflect across that, the function and its inverse. They're mirror images across that line. If I were to fold it on that line, they would match up. Now I did all that. I graphed it. I did the domain and range without even having the equation of the inverse. Okay, just knowing that x and y switch. But to actually find the inverse, I'm going to follow those steps. Oh, I didn't mean to switch that line. I'm going to actually follow those steps written above here, these here. So I'm going to change that to be y equals x minus 1 squared plus 2. Now I'm going to switch the x and the y. I'm going to solve for y. So I want to isolate the y. I'm going to move this 2 over by subtracting. Can't combine those, so just leave it as an expression. Now I need to get rid of the square. So I'm going to take the square root of both sides. Now when I take the square root of both sides, we are used to putting a plus or minus in front of our square root. But remember our restricted domain, we only want the positive square root. So we're not going to do that when we're taking the square root here. So I take the square root of both sides, which gets rid of that square. If you need to show up here, taking the square root and those eliminating, you can show that. And then I need to add 1 to both sides. Now this 1 is not going to get added to that 2 because that minus 2 is under the radical. This plus 1 is not. So make sure you keep that separate. The plus 1 is outside the radical. Now this is the inverse that I came up with. And then I'm going to rewrite that. F inverse of x equals the square root of x minus 2 plus 1. And you can confirm that that's what we graphed. You can type this in Desmos and see the values that we came up with. But this is the square root function, and it's shifted right 2 up 1. So normally it's at 0, 0. We went right 2 up 1, and there's that endpoint. So it all looks good, but you can definitely confirm this in Desmos if you feel the need to. All right, let's try one more. Actually, I guess there's 2 on this page, but not positive we'll get through both in this video because my lunch break's about to be over and the bell's gonna ring. Let's go ahead and graph this. We're starting with a square root this time. So it is shifted up 5. It's the square root function shifted up 5. So here, and then we know the over 1 up 1 or over 4 up 2. Hey, you can do this if you don't know the parent function well enough to do that by hand. It's not a big deal. You can go in Desmos and get these points. You could even get an additional one. I didn't plot, but you could get those. So the domain here is from 0 to infinity. And the range is from 5 to infinity. Now, if you want to write that in interval notation, again, that's just x is greater than or equal to 0. This is y is greater than or equal to 5. Both of those notations work just fine. So I can go ahead and fill out the inverse info. I'm just going to switch my x and y's. And I meant to do this in a different color again, dang it. So the domain here will now be x is greater than or equal to 5, and the range will be y is greater than or equal to 0. Remember, the domain and range are going to switch. So then if I go to plot these new points, 5, 0, 6, 1, 7, 4, and here's that curve. Now, when I graph this one, these are going to intersect like that, and you can add that line, y equals x, and you can see they intersect on that line, and that's what should happen when you have inverses. If they do intersect, they should intersect on that line, y equals x. So it looks good graphically. You can plug this in and look at it in Desmos and confirm. But now let's go ahead and do the algebra of actually finding the inverse equation. So it's y equals the square root of x plus 5. I'm going to rewrite that by switching the x and y. Now I'm going to solve for y. So I'm going to subtract 5 from both sides. Now I'm going to square both sides to get rid of the square root. Now the entire other side gets squared. Make sure you're doing the other side completely. So I've got x minus 5 squared is my inverse of f of x. Okay, so that's what we came up with. And now that's the quadratic function just shifted to the right 5. And so you can see that in the graph. This is just your parent parabola shifted right 5, but notice it's only half the parabola. So we need to indicate that when we write this function, because if I were just to graph this, I would see the whole parabola. So I need to make sure I'm restricting the domain to just that x is greater than or equal to 5. Now I set it over here, but I just need to list it next to the function to make sure that that is seen. So make sure you write that restriction. Now that's what I want to show you in Desmos, that you have to write that restriction. So here, I go to Desmos. I've already got my y equals x line there because I like to see that there. I'm going to graph the original equation is the square root of x plus 5. And the inverse we came up with is x minus 5 squared. Now here's what I'm saying. It's going to show you that whole parabola unless you write the restriction. So we need to write the restriction for this. And I'm trying to remember, I think we do a comma and then our braces, x is greater than or equal to 5. And then close the braces. No, not quite. Maybe we take the comma out. Yeah, so you don't need a comma. So you'll just write the equation and then use those braces to put your restriction. And now it will graph just that half of the parabola. Okay, it'll have that restriction in there. And we can see that looks good. That looks like what we graphed over here. Okay, so that's how you'll type your restriction. And if you try to type your restriction in interval notation, like saying that it's 5 to infinity. Well, there's actually no way to type infinity, so you can't do it that way. So you definitely have to type your restriction as an inequality to see that restriction. And there's no comma or anything. You just type your equation and then the braces with your restriction in it. So that's how you do that in Desmos. I'm out of time. The bell just rang. So I'm not going to walk you through in the video this example. It's very similar. But I'll post in with the completed notes. I'll have this one worked out. If you want to try this one and then check it, that would be a good way to practice. So I'll post the completed notes. They're right under this video in our Canvas. And then you've got a practice assignment in Delta Math.